Hi all, in this video I am going to explain how to solve a given problem using nodal analysis. What is nodal analysis? Nodal analysis is a simple technique when compared to the Kirchhoff's voltage law. And using nodal analysis, we have to find out nodal voltages as well as nodal current. Nodal analysis is the combination of KCL, that is Kirchhoff's current law, and Ohm's law. What is Kirchhoff's current law? Kirchhoff's current law states that sum of the current flowing towards the junction equal to sum of the currents flowing away from the junction. What is Ohm's law? At constant temperature, a current flowing through any conductor is directly proportional to voltage across it, or V is equal to IR. Now I am going to explain what are the steps needed to solve this. There are 3 steps needed to solve this nodal analysis. Step number 1. First of all, find the number of nodes in a given network. And next, you have to put the voltages corresponding to the number of nodes. The voltages may be V1, V2 and so on. Next, what is node? Node is the junction of 3 or more branches. That is known as node. Or 3 or more branches connected to one common point, that is known as node. See here, 4 ohm, 3 ohm, 8 ohm are connected together. Here we are having the nodal voltage V1. 3 ohm, 5 ohm and 6 ohm are connected together. Here the nodal voltage is V2. Then what is the step number 2? Step number 2, assume the direction of current in each branch. Here, all the currents are flowing away from the junction. Current in each branch. You see here, the current is flowing away from the junction. Current is flowing away. Here also flowing away from the junction. Then what is the step number 3? Apply nodal analysis. As I have already told that nodal analysis is the combination of Kirchhoff's current law and Ohm's law. How to write the equation? First of all, I am going to consider the voltage V1. I am going to write the equation with respect to V1. First consider the 40 voltage and 4 ohm resistor. The 40 volt, what about the flow of current negative to positive? See, this is the current. Compare both the current. Both are opposing with each other. How to write the equation? V1 minus 40 divided by what resistance? 4 ohm plus V1, here this is the ground terminal, 0 voltage, V1 minus 0 by 8 plus, with respect to V1 we can write the equation, so V2 is considered as negative. So V1 minus V2 divided by 3 equal to 0. Next I have to separate the variable and constants. So V1 of 1 by 4, here 1 by 8 and here 1 by 3 minus V2 by 3, that is equal to minus 40 by 4, that is 10. Okay, then I have to reduce this equation. What is 1 by 4? 4 inverse plus 8 inverse plus 3 inverse. That gives the value 0.7083 V1 minus 0.03333 V2 equal to 10. This is the equation number 1. In the similar manner, I am going to write the equation with respect to node V2. How to write the equation? See, first of all I am going to write the equation V2 for 3 ohm resistor. So V2 minus V1. With respect to V2, I am going to write, so V1 is negative divided by 3. Then V2 minus 0 by 6 because ground potential, that is 0, plus V2, here there is no voltage. One current source is there. The current source, if the resistance have no effect on this current source. And see the direction of the current source, both are opposing with each other. So how to write minus 5, that is equal to 0. Because this is the current, this is the current. Directly we are having the current, so you have to substitute the current like this. Next I am going to separate the variables. V1 of 1 by 3 plus V2 of 1 by 3 plus 1 by 6. That is equal to 5. Now I am going to reduce this using the calculator. 0.333 into V1 plus 1 by 3 plus 1 by 6, that is 3 inverse plus 6 inverse, that gives the value 0.5 V2, that is equal to 5. This is the equation number 2. So after getting these two equations, what I am going to do, I am going to apply the matrix method to solve this equation. So I have to write the equation separately. First equation is 0.7083 V1 minus 0.3333 V2 equal to 10. The next equation 0.3333 V1 minus plus 0.5 into V2 equal to 5. Equation number 2. Now I am going to write this in a matrix form. How to write this? 0.7083 minus 0.333 minus 0.333, 0.5. Here write what? V1, V2, 10, 5. Have to write like this. And next find out the voltages V1 and V2. What is the formula? Delta 1 by delta. That is V1. What is V2? Delta 2 by delta. In this way, we can find out the value. So first of all, I am going to find out the delta. So what is delta? Delta means you have to write this matrix. 0.7083 minus 0.3333 minus 0.3333, 0.5. I am going to find out the determinant. So the determinant directly it is obtained from the calculator. That is 0.2430. In the similar manner, I am going to find out the delta 1. How to find out the delta 1? The first two columns, first column is removed. Instead of the first column element, have to place this 10 and 5. 0 point remaining elements, there is no change. 0.5. That is equal to what? Directly it is obtained from using the calculator, that is 6.6665. So this is delta 1. Next I am going to find out delta 2. How to find out delta 2? For delta 2, second column element should be removed. Instead of this, I have to place 10 and 5. And first column 0.7083 minus 0.3333. What is the determinant value? That is equal to 6.8745. These are the values obtained. After getting this value, I am going to find out what are the values V1 and V2. V1 is delta 1 by delta. What is delta 1? That is 6665. What is delta? 0.2430. The answer is 27.43 volt. And next I am going to find out V2. V2 is what? V2 is delta 2 by delta. That is 6.8745 divided by 0.2430. That is equal to 28.29 volt. These are the voltage obtained from the nodal analysis. Thank you. Have a nice day.